Aloha, Richard Halverson here. This is ITS 128, and in this video I'm going to do project 8.4. So if we look at the problem, this is it. It's called Markov Matrix. An n by n matrix is called a positive Markov matrix if each element is positive and the sum of the elements in each column is equal to 1. And so we're supposed to write a function to check whether a matrix is a Markov matrix. And this is what the function, this is how we call the function. M is going to be a matrix. And so we're going to write a test program that prompts the user to enter a 3 by 3 matrix of numbers and tests whether it is a Markov matrix. And so note that the matrix is entered by rows, and the numbers in each row are separated by a space. So it's going to look like this, where your program prints out, enter a 3 by 3 matrix row by row, and then it's going to accept this as an input, and this as an input, and this as an input. So it's going to have 3 inputs in a row, reading in these strings, and then it's going to do its processing and adding up each of the columns, and then it's going to display out whether it's a Markov matrix or not. In this case, it is, because when you add 0.15 and 0.55 and 0.30, you get 1. You add 0.875 plus 0.005 plus 0.12, you add that up, you get 1. You add 0.375, you add 0.225, and you add 0.4 together, and you get 1. Therefore, you get 1 in all 3 columns when you add up all 3 columns, and therefore, it is a Markov matrix. If you add them up and it's not that, then it's not a Markov matrix. All right, so let's get started here. I'm going to start up a new, this was from the last time. Let me clear this out. And I'm going to start by putting this in there. These are the 2 cases, so let me just copy these 2 cases in. And I don't really need this here. All right, so let's get started. I'm going to first let's load up the matrix. So I'm going to start with matrix equals. I'm going to declare the matrix, and then I'm going to print out I'm going to print out enter a 3 by 3 matrix row by row. Copy, paste, and then I'm just going to enter 3 rows, right? So for R in range of 3, I can just read in the rows one at a time, and I can just do this input. Doesn't need to display out anything. And then I'm going to append. Okay, so I'm going to take that row, I'm going to split it up. I'm going to split it, make sure that I'm reading the numbers, reading them then in as floating point numbers. And so to do that, you recall matrix append, and we do this kind of declaration like that. Inside there, we're going to say for I in row of split. So for each I in the split up row, so I is this, I is this, and I is this, except for we want a floating point version of that. So we say float I like that. And so this is going to go I for all of the elements when this is split, and this is going to convert it to a floating point. and that row will be appended to this matrix. So this is going to read in the matrix one row at a time. And so let's print this and see what it looks like. Print matrix, just to see what it looks like. Make sure we've got it in there right. Let's run this and see what it looks like. And I don't need any of this. Python test y, test.py. So enter in a 3x3 matrix row by row. Now, what I can do here is I can just do, I can enter in all three of these rows. Well, let's see, let me first show you how to do this. I can copy this, copy, paste, enter. Copy this one in, paste, enter. Copy this one in, copy, paste, enter, and we see that it displays out the matrix just fine. This is the first row, this is the second row, and this is the third row, and we see that it does enter into each row correctly. All right, so I've got the matrix read in, and now I need to check to see if it's a Markov matrix. So I'm just going to have something like, I don't need this anymore. If, and I'm going to have to create this function, is this. I'm going to have this, copy this here, and I'm going to put this at the top. So I'm going to write that. If is Markov matrix, and we're going to pass in matrix. If it's true, then we say print it is a Markov matrix. Otherwise, we print it's not a Markov matrix. It is not a Markov matrix. All right, so how do I do this Markov matrix? I'm going to start out by going, let's see. I'm going to have to go each column at a time. Didn't I do something that added up columns? I think I did, didn't I? If we go back to our if we go back to, let me open up project number 1 here. You remember this project number 1? This thing sums all of the elements in a specified column. Okay, so this sums this sums a column in a matrix. That's what sum column does, right? Write a function that returns the sum of all the elements in a specified column in a matrix. So I want this. I'm going to copy this function, copy, and I'm going to put it over in my new one here. I'm going to put that above here. Just like that. Okay, I'm going to use this function here. I'm going to use this function. This was my project, my first project. In fact, really what I should do is I shouldn't do it that way. I should go here. Let me close this out and go back to project number 1, question number 1. Oh, no, I don't have the answer here, do I? Oh, well, I had the answer the other place. Okay, anyway, I don't need to do this. Okay, so I've got this this function that I grabbed from the first project, and I'm going to use this. All right, so I've got this matrix here. I've got this function I'm trying to write, and I'm going to I need to look at all the columns in the matrix. So I'm going to start out by setting the column equal to 0. I'm going to use a while loop, because as I'm adding up the columns, if I find that the first time I find a column that doesn't add up to 1, then I'm done. I know it's not a matrix. I know it's not a Markov matrix. So I'm going to use a while loop for that. I'm going to start out initializing a variable is Markov equal to true, and Markov will equal true until I determine it's not true. So while the column is less than the length of m of 0, this would be the first row. The first row of the matrix. This is a matrix coming in. This is the first row of the matrix. The length of the first row of the matrix is the number of columns in the matrix. So while C is less than the number of columns in the matrix, and we still believe that it is a Markov matrix, while this is true, then we can say that if the sum column, that would be this, of M and C, starting out with C equals 0, if that is equal to 1, then we still know it's a Markov matrix. So if it's not equal to 1, it's not a Markov matrix. If it's not equal to 1, then it is not a Markov. Is Markov equals false. Okay? So we're going to loop. If we find that a column sum up a column that's not equal to 1, we're going to set that equal to false. Either way, we're going to increment C to the next column, and then we come back around here, and either this loop will terminate if we find that one of the columns does not equal to 1, or if we find that C gets incremented up beyond the number of columns in the matrix. So this is going to keep on incrementing, and we're going to keep on testing, and if ever this is not true, C becomes not less than the number of columns in the matrix, or if we determine that it's not a Markov matrix because we added up a column and it didn't equal 1. If either of those cases is true, then the loop will terminate, and we're done. If we make it all the way up where C becomes equal to the number of columns and it's still a Markov matrix, then we know that we have found a Markov matrix. So here we can just return is Markov. Okay. So what we're going to do is we're going to first build up the matrix, and then we're going to test to see if it's a Markov matrix. And this thing is going to test the whole thing. Each time it's going to use this sum column function, which will look at a particular column in the matrix and add it up. We did this in project 8.1. Now this might just work. I'm going to test it. Hello. All right, let's run this. And what I was going to show you before is I can just take this and cram these together like this. And I can just copy this thing here, complete with the return characters. Copy, paste. There it is. This last enter, and it says this is a Markov matrix. Well, that's great. let's test this one. Copy, and I need to run it again. And now I just need to paste it, enter, and we see it is not a Markov matrix. Alrighty, well, that should help you out with project 8.4. You need to fix it up a little bit so it inputs and outputs exactly like it shows in the question. So the input and output look just like this. And we're pretty close. So hope this helps. Thanks for watching.